Today I would like to talk about adaptive pairing and circular production. As you may already know, humanity faces some really big challenges in the future, and one of them is resource consumption. So there is different statistics, and you can see that, for example, the European Union is right now importing 101 billion euro worth of raw materials. And according to an organization called Overshoot Day, we currently are using 1.75 Earths per year, so 0.75 more than Earth can actually regenerate. At the same time, we have different production network issues. As you may know from the corona pandemic, we had a lot of issues with our supply chains, and so we saw a huge rise of such issues. Luckily, there could be some measures to help with these issues, and one of these measures is the circular production. What is circular production? Circular production is the concept of reusing old products and remanufacturing in such a way that you can sell it as quite as a new product. And there are different concepts in circular production. Recycling is quite well known already, so you can see if you have here the value chain starting from the raw materials going down to the customer, that recycling means bringing the product back to the raw materials. And as I shortly mentioned, there's also the possibility for remanufacturing. Remanufacturing is not turning down the product back to raw materials, but instead brings it into the manufacturing process and tries to save as much value as possible. And in literature you can see that remanufacturing has a lot of potential, so it can save a lot of energy in different industries and especially save a lot of resources. There are some possibilities for remanufacturing, especially products which are changing only little from product generation to product generation are suitable for such a case. One example is here the power tools. As you can see here in the different generations, there's a lot of common parts, and this is prone to be reused actually. But the thing is, when you're in the circular production, you may encounter a problem, and this is the problem of the recombination of product parts. If you have different product parts which are at the boundary of the tolerance, the recombination of those product parts can lead to a product that overall is outside of tolerance and not functioning anymore. Therefore, I would like to propose the use of smart quality control strategies in order to recombine products and to remanufacture products in such a way that you are in the end having a functioning product. So how can this look like? You can see here different strategies for spare part manufacturing or remanufacturing and reassembly. So on the one axis, you can see you can do a classic manufacturing into the specifications, and you can manufacture into different classes as you have maybe already some experience about remanufacturing, or you can do an individual remanufacturing. So you manufacture a part in such a way that it adapts to your quite as new product. On the other axis, you can distinguish classic recombination of parts, so no adaptive remanufacturing or adaptive pairing. You can do the same in classes, and you can do a unique pairing of components. And not all combinations do make sense, but what I want to focus on today is the individual manufacturing of parts and the individual pairing of parts. And what do we need for that is that we have some kind of a product twin, a production twin, in order to simulate the function of the remanufactured or reassembled product. Because only if we understand how the product works, we are able to assemble the components in such a way that we get a functioning product. Furthermore, besides the product twin, we need a quality control loop. And this quality control loop starts by taking the product and doing a first measurement of the product. And this measurement is fed into the product twin. Additionally, you can consider, of course, with this product twin, a clever remanufacturable design. And of course, you can use this data to do the adaptive manufacturing of other parts to fit with your new part in the inventory. After that, you need an individual pairing of those two components and a functional measurement to gain more knowledge about the working of the product. The solution space is bound by different factors, so the size of your inventory, obviously. So if you only have one part, you cannot recombine. I think it's quite obvious. And then the manufacturing capabilities. Are you able, with your production system, to pair individually and to manufacture individually? That's quite a challenge. And the allowed design space is also an issue. If you have very tight specifications from the designers and are not allowed to modify the product, you can also not do a clever circular production. To give you a short example how this could look like, here we have an example of the starter motor. Starter motor is already a common part of remanufacturing. It's already remanufactured, but only manually. This is a starter motor from the company Bosch. Here are different quality parameters you could look at. For example, you could look at the gears if they are broken, the wear of the brushes, or rust on the casing. And you could imagine to reuse, for example, if you have one starter motor where the brush is already broken, but the casing looks good, and you have a different starter motor, maybe in an environment such as Copenhagen, where you have maybe a lot of salt in the air, where you have a lot of rust, but you haven't used the starter motor so much, you could, for example, take the non-rusty case and reuse it for the non-so-used other starter motor to get a as-new product. Other application could also be, I missed translating that, could be the fuel cell. It's quite a new product and it's really interesting for the circular production because the biggest cost factor of a fuel cell is the material. And therefore you could become a lot more competitive when you are able to build up a business model with the circular production of the fuel cell. So some outlook for the future. For the inventory, there's not a lot possibilities, so there's just a trade-off. The bigger your inventory, the bigger the capital expenses are. Of course, the smaller the inventory is, the less possibilities to combine you have. With the manufacturing capabilities, there's also already a lot of work going on. So if you have a look at the state of the art, and I would like to propose that we have in the future more interlinkage with the designers. Because I think if designers design more in a function-oriented way, or even with more based on an AI model way, there would be a bigger space for production to do the circular economy. So thank you very much, and that's it.
Thank you, Florian.